Hey guys, what's up? I hope you're doing great. Back with another video, and in this video we are going to study two pointers and sliding window. Now sometimes these topics are considered completely different, but they have a lot in common, and whenever I have taught them even in past, I always try to club them, because if you understand how two pointers gets converted to a sliding window, it really becomes easy for you as well, so as to apply these two algorithms whenever required by just looking at the problem, or it actually leaves you in a scenario where you are more capable to properly utilize these two algorithms. So what we'll do is, firstly we'll understand what two pointers is, we'll solve a problem from code forces, then we'll come back over here, we'll try to understand how do we modify two pointers to convert it into sliding window, and then we'll solve a lead code problem based on it. And that way we are going to cover these two topics in just a single video by solving two problems and obviously theory part. So let's get started with two pointers, of course. And as the name states, two pointers is basically having just two pointers on any data structures. Now it could be a graph or a tree, or it could be a linked list, or it could be a array or string or anything of that sorts. So basically just having two pointers on a data structure, so that it helps you to compute something, that's called two pointers approach. That's pretty vague, but let's look at an example. Now let's say I give you an array. Now for the simplicity purposes, I'm not going to discuss graph, trees or linked list over here. I'm just going to focus on arrays. So let's say this is an array that's given to you, and let it be zero indexed. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8. Now over here, you have two pointers. So this is your first pointer, let's call it I, and this is your second pointer, let's call it J. Now based on the values these have, let's call it val I, let's call this val J. Now based on the val I and val J, we do some computation, and then we either increment I, or we increment J, or we decrement I, or we decrement J, any of operation of that sorts. And based on that, we are able to compute a final answer, that this kind of becomes a valid two pointers approach or two pointer algorithm. Now in most of the cases, what you'll essentially be doing is that either you'll be starting with your I over here and your J over here. Now just understand that I'm saying in most of the cases there would be exceptions over here. So a few common patterns would be that for the array you'll be having your I over here and your J over here, and in each iteration, and then you'll be moving your I to the right and your J to the left. Or it could be the case that you'll be having your I over here maybe, and you'll keep incrementing your I, and your J would be at the beginning, and based on some condition or workflow, what would happen is that when certain conditions are met, your J would also start moving to the right. And these are basically the two scenarios that you'll mostly see in approaches that use two pointers. There could be another scenarios, but I'm just talking about the most common ones. And one of the problems that we're going to solve today is also based on this particular scenario that we have just discussed right over here. And there's not much to discuss in two pointers, and that's pretty much all you'll actually use in almost every problem you're going to solve using it. Yes, specifically talking about the arrays part. So let's get started with code forces, and when we'll try to solve a problem, you'll be able to understand how the algorithm is actually working, and you'll also be able to see the code. And trust me, if you're able to solve one problem on two pointers, then it really becomes easy for you to solve multiple problems on it as well, as the concept really doesn't change much. So let's move ahead to the problem. So the problem states that you have an array A of size n consisting only of zeros and ones. You can do the following operations. You can choose two indices, that is I and J, and we can add AI to AJ and then remove AI from A. So basically adding one value to the other and then removing the first value itself. Note that the elements of A can become bigger than 1 after performing some operations. Also note that n becomes less than 1 after performing the operations. So basically they mean that if you add a 1 to a 1, obviously it will become a 2. So yeah, it can become bigger than 1. And once you are done with the operation, you're going to remove the first number, right? Or basically you can say you are going to remove A of I. So the length of the array would obviously decrease by 1. So that's what they mean by the second line over here. Now they ask, what is the minimum number of operations needed to make A non-decreasing. That is, that each element is not less than the previous one. So basically, a sorted sequence of the sorted sequence is all we need, and we have to tell them the minimum number of operations needed. And this is a two pointer, a classic two pointer problem. For example, over here, it's already sorted, so you don't need any operation. Over here, what we can do is we can say that, okay, this and this number, let this be AI, let this be AJ. So what I'm gonna do is I'm gonna add 1 over here, and this would get removed, so this would become 0 1 1 1. So yeah, it just requires one operation. Similarly, over here we can say that this is AI and this is AJ. So AI would get added to AJ, so this would become simply a 1. So again, over here we need one operation. But one easy thing to note over here is that if you have an array, the way we can say it's already sorted is that there should be some zeros and then all ones. Now this is a star sequence. What do I mean by that? Basically, zero or more occurrences are fine over here. So you can say it's 0 star 1 star. I think this is taught in TOC, theory of computation, but anyway. So this basically means that there could be any number of zeros, 0 or more occurrences of 0 followed by 0 or more occurrences of 1. So this would mean that this is a valid sequence. This is a valid sequence. And obviously some zeros followed by some ones are also valid sequence. However, a valid sequence is not one wherein there is there are some zeros, then there's some one, and then there is a zero, right? Or there could be a few ones and then there's zero. So basically, the moment you get a 1, there should not be any zeros to the right of it. If that's the case, then it's not sorted. So this is a very easy definition to understand. Based on it, what we can say is that we'll start traversing our array. So let's say we started traversing and we were getting all zeros. The moment we get a 1, now there arises a problem because we don't know to the right of it, do we have a 0 or are there all ones? So it could be the case that it's 1 1 and then there are a few zeros, right? And then there could be 1 1s too. Now what would we do in this case? What I would suggest is that let's utilize this. Let's call this A of I, right? Let's call this A of J. But why this particular 0 itself? Because this is the rightmost 0 available to me, right? I could have just replaced this 1 with this 0 itself, but that wouldn't have been optimal for me. The simple reason being, let's say there was a 1 and then 3 zeros and then 1 1, right? And then there was all zeros over here. Now in case I would have replaced it over here, it would have become, or you can say if I would have taken this out and added a 1 over here, then it would have become sorted, right? Because it would be all zeros followed by all ones. But now if I replace it with this particular 0, that would give me all zeros and then a 1 and then 0 zeros and then 1 1 1. It's again not sorted. So in order to sort it, the easiest possible way for me is to use AJ as the rightmost 0 available to me. That's what I'm going to do. So I'm going to take this up. I'm going to consider it as AI. I'm going to consider it as AJ. And I'm going to make this 1. And this is going to get busted, or this is going to get removed. Now in the second iteration, I'm going to again increment my AI. And by this time, I already know that my AJ was here, but AJ was already made 1 in the previous step, right? So I'll have to move my AJ to the left. As I move to the left, I'm again able to see a 0. And again, this is the rightmost 0, of course, because if my AJ is over here, if my AJ is at or if my J is at a particular location, that basically means all the elements to its right are already 1s. So if it's a 0, then I for sure know that it's the rightmost 0 available to me. I'll perform the same operation over here and then the same operation over here. Let's look at a new example, because that was not a great example because there were 3 zeros and 3 1s and 3 zeros consecutively. but this would make more sense. Now let's say this is a 1 0 1, maybe like a 0 and then all ones. Initially your I would be here and your j would be here. Now in each iteration we'll try to move our I forward. So we'll go from here to here to here to here to here. We land at this particular location and then we see it's a 1. Now we say that we don't know if there's a 0 to the right of it or not. In that case, what we'll do is we'll start moving our j to the left hand side till the time it's less, like it's greater than I, and also it's having a value 1. So yeah, over here it's greater than I, still having a value 1. Over here it's greater than I, still having a value 1. Same over here. Now it reaches this point. It says right now I'm still greater than I. This is I, right? Basically, when I'm saying it's greater than I, it basically denotes the index and not the value. So yeah, by index it's greater than I, but now it's having a value 0, and now j can assure itself that it's the rightmost 0 available because it has come from the rightmost location and there were no zeros over that. So now it'll say that okay, this becomes my ai, this becomes my aj. Now let's perform the operation that your aj is equal to ai plus aj and remove ai. Let's perform that. So I'm gonna remove this. This is gonna get removed and this is gonna get incremented to 1. Right? Now what? Now in the next step also, this is gonna move over here. This is gonna say that I am I. I is gonna say you are 0. Let's move to the next one. It's gonna move over here. It's gonna say it's a 1. But now j is over here. As soon as let's color it with a different color. Now j is over here. As soon as your j tries to move to the left, I is no more less than j, or j is no more greater than I, because essentially it will point to the same location and our algorithm would close. And as soon as our algorithm closes or our iteration closes, you would be in a state where you can definitely assure that all the elements are already sorted. The reason being, from the left hand side, you have all the zeros because as soon as you were finding a 1, you were replacing it. And from the right hand side, you have all the ones because as soon as you were finding a 0, you were replacing it. So it becomes a sequence of all zeros and all ones, which is obviously sorted. On top of that, the way you did it was having 2 pointers, one which was starting from the left and the other which was starting from the right. By definition, it's a 2-pointer approach, and we were also able to prove it by why the solution actually works. Now another thing to note over here is that essentially we are removing the elements over here. That's one way of doing it, but removing or not actually doesn't matter. The simple reason being that in our algorithm, the elements, the way we have implemented it, the elements we are always saying we are going to remove are actually zeros itself, right? Now having maybe like a few occurrences extra of zeros to the left really wouldn't change our answer, but it would make our implementation more easier. But anyway, not bothering about that too much. Let's jump on to the solution. I hope the explanation was lucid. Let's try to understand the solution. I do have a submission over here. I could code it from scratch if you need, but who's here to waste time, I guess. Cool. So what I'm doing is, firstly, I'm taking the number of integers and then the vector itself. Now the way I actually take the entire vector in a single sequence treatment is right over here. If you want this particular snippet, you can take it from any of my submissions on Codeforces, or this is also available on the GitHub repository of Acodedaily. You can clone it from there. Then what I'm doing is, I'm starting my iteration or my for loop, inside of which I am initializing 2 pointers. The first one being I, that is set to 0, and the second one being j, that is set to the last element of the array. And then this would continue till the time my I is less than j, and in each iteration I'm going to increment my I. Then what I'm going to do is, if the current element is a 1, only in that case there's a possibility that there could be some zeros to the right of it. So what I'm going to do is, till the time my j is greater than I and j is not pointing to a 0, because if it's not pointing to a 0, it's pointing to a 1 and it's a valid element. So if that's the case, I'm gonna keep decrementing it, right? Now, once it's out of it, there could be only two reasons. Either now your j is equal to I, or your j is now pointing to a zero. Now, if your j is equal to I, that basically means your entire array is already sorted. But if that's not the case, then you need to, utilize that particular operation. So if your j is equal to I, that means the entire array is sorted. You can break it. If that's not the case, then you need to apply that particular operation. That operation being that you'll add ai, or over here my vector is v. So you'll add vi to vj and remove vj. But it really doesn't matter over here, because for a fact my vi is 1, my vj is 0. So my vj is going to become a 1 and my vi is going to get removed. But since to my left, if I'm adding some more number of zeros, it's not going to matter. So just for the sake of simplicity, I'm just swapping it. So even by swapping, my vj would become a 1 as it was supposed to become, and my vi would now become a 0, which technically should have been removed, but it really doesn't matter, because again, a few more zeros to the left of it won't hurt. And yeah, after that we are going to increment a result, because we definitely performed an operation, and then just print out the result. It's as easy as it. And obviously, when I explain the problems, I would expect you guys to at least solve them on your own. This would even give you confidence and would improve your implementation skills. And if you just want to take a note, this is the B problem from Code Forces Global Round 23. Cool. With that, let's move to sliding window. And in sliding window, we are going to solve a medium problem from lead code, and we are going to solve it in C++ itself. So let's come back over here. Now, what does sliding window mean? Now, in 2 pointers, we were having 2 pointers, right? However, if I say that based on these two values, I need you to calculate whatever is inside this particular window. So if you look at it, this is your integer I, this is your j. Your array can be bigger than this. Yeah, there could be some more elements over here. Now let's consider the subarray that it's enclosing. Now let's consider I to be the left limit and j to be the right limit of the subarray. So this becomes a window, right? This is a window. Now I might be interested in knowing certain properties of the elements that are enclosed in this window. It could be the XOR value, or maybe the sum of all the elements, or the number of unique elements. So it could actually be anything. Now, if based on the value, whatever is enclosed in this particular window, if I'm able to derive my final solution, or if my algorithm relies on this particular thing, then it's called a sliding window. But wait, a window we do understand, but why is it called a sliding window? Because more often than not, what would happen is, in your iteration, you'll move j, but as soon as you move j, if certain conditions are met or if they are not obeyed, either could be the case, your algorithm might rely on the conditions being met, or your algorithm might rely on the conditions being broken. So in those cases, you might need to slide your I. So if you look at it, what is happening over here is your I now comes over here. So your window actually shifts a bit to the right. And obviously, you can replace I and j. What I mean by that is, I could be a front pointer, j could be a back pointer. Anything is possible here. But essentially, in the iteration, your window is sliding. It could slide to the right or to the left based on the algorithm. But since it's a window which is sliding, it's called a sliding window algorithm. And right now, the problem that we are going to solve from lead code is something that I guess would rely. Let me just read the problem again. Yeah, it's basically a window wherein there's no repeating characters. So let's just add it to the definitions over here as well. A window with no repeating characters. No, not number, but no repeating characters. Now the benefit of sliding windows that obviously over here, a very easy or brute force n-square solution would work. However, by using sliding window, you're able to reduce the complexity of a program to just order of n from order of n square. That is a brute force solution. And this really doesn't use any advanced or even medium level data structures, it's really easy to code. So I'll code along the way, and you'll be able to understand it. So obviously, since we are talking of having unique characters in the substring, I'm gonna use something for calculating the frequency of each of the characters, or I can just use an unordered map. That would be of char int. That basically means I'm gonna have the frequency count for each of the characters inside my particular window. Now I'm gonna start my loop. So I'll have two pointers, as the name states. Initially, both of them are at zeros, and then I'm gonna go to n. N is basically the size of the string, which I have not defined because I'm dumb. But yeah, cool. And also I'll have to have a variable which can store the value and then can return it. So let's call it res, and then at the end we are obviously going to return the res. So res basically means the result. Over here, what I'm going to do is, so in this loop, my I is getting incremented every time. So I'm just going to write over here, I is my forward pointer. I'm going to write it as forward pointer, and my j is the backward pointer. Back pointer. Okay. So since I is obviously there in the current loop, I'll say that if my frequency, or let's just increment the frequency of s of I, because I know that I is definitely there. Now if your frequency of s of I is not equal to 1, that basically means the frequency of this particular character is more than 1. It would be 2. So what should we do in that case? In that case, we'll have to move the left part of our sliding window. So basically this particular part we'll have to move, because now what we are saying is that so this was the array or the string. Now over here, let's say there was a certain character, let's say f. Now the frequency of f has become 2. We obviously want to include it. That basically would mean that we'll have to exclude the last possible value of f, or we'll have to exclude the last value of f in this particular array. And we are having a pointer j over here. So what we'll do is we'll keep incrementing it till the time we are able to come to a point where an f is present, and then we'll decrement the frequency of f, because obviously now we are gonna shut our subarray over here. So we're gonna decrease the frequency of the character. And then we can say that now this particular array, or this particular subarray, or this particular window does not have any character with frequency more than 1. Cool. So till the time the frequency of s of I is not equal to 1, or if it's not equal to 1, then what we'll do is, or we should rather use a while loop over here, because we obviously want that the value should become equal to 1. There should be a single occurrence. Till the time that's not happening, I'll have to increment my the left side of the window. So what I'll do is, I'll say that the frequency of s of j can be decreased, because I'm gonna increase the point to which it's pointing. So basically I'm incrementing my left side window, and since I'm doing that, hence its count can be reduced. And at some point in time, it would come to a value, this frequency becomes equal to 1. As soon as that happens, this loop would break, and right now the two pointers would be pointing to a subarray or a string which has unique count of each character. So I can say this is definitely valid. And what's the length pointed by these two pointers? So that would be I minus j plus 1. And yeah, that's pretty much it. Yeah, that works. It always feels great when your solution works in the first go. I think that's pretty much what you need to understand even about sliding window. Now obviously there can be more tweaks to it. There can be different kind of problems can be formed by it, and this is a medium level problem. So you can just say that these kind of problems are the ones you are obviously going to face a lot in interviews or OAs. But also two pointers is a very well known topic in CP as well. So I hope this video is able to help you. Let's try to submit it. Yep, it works. Cool. So I hope this video is able to help you out in understanding what's two pointer and what's sliding window and how they are related. And like always, you'll be able to find a lot many problems in the description section of this video. I hope you try to solve these problems, and whenever you face any difficulties, just ping on the Discord server. More than happy to help you out. Cool guys, thanks a lot for sticking till then. Bye bye.